So here's my second piece of software assignment. It's in controls. And in the class, we talked about how to make a car follow a straight line. We used the line x equals 0, where the cross-check error was defined as the y difference between this axis. We just read off the y value. So now I want to make a more interesting course, a cyclic course, a race course. So here's my race course. It has a radius r, which you can set. And the way I'd like to define this race course is through a half cycle of radius r, same half cycle over here. And the stretches in between I want to be 2r long. So for example, this radius equals 25 meters. Then this will be here 50 meters. The whole thing will be 100 meters. And this dimension will also be 50 meters. I want you to program it such that the initial car is stationed right over here, pointed upwards. And then it drives onto the race course like this, all the way around infinitely often. The key in doing this is going to be to set a function. I have already modified for you the function run from our control class to use that cross-check area with the parameter radius, which we're going to set to 25, but I can pick a different value in my testing. And then I've modified a little bit the update over here to maintain the differential and the integral cross-check error. And here's our steering control law that you're familiar with. Instead of twiddle, I'm just going to give you parameters 10, 15, and 0. Those work fine for me. And they're actually the result of running twiddle without the integral part. And then when I run it, I get my output. And here it is. The cross-check error by and large is very small. You can see the steering tends to be on the negative side. Here we're steering in the first turn. Here we're in the straightaway. You can see this by the magnitude of the numbers. Here we go into a turn again, so the turning becomes larger. In all of this, you find the cross-check error to be relatively small, about 0.1 or so, not very much. And this continues and continues. The final cross-check error for the second half of the race is 0.005. So you want this number to be really, really small. Now the tricky part is, when you code this up and code the function CDE, you need a different branch for this area here, for this area over here, this area over here, this area over here. Keep in mind that the robot is going to go in a cycle, so it's going to traverse this one in the opposite direction with this one over here. So good luck coding up the correct cross-check error function.